Chapter 20, Video 4, Calculating the Avogadro Constant by an Electrolytic Method. So you know that Avogadro constant is the number of molecules of particular particles, so of that specified particles in a single mole. So to find the value of Avogadro constant, we can use the transfer of electrons in an equation. Then from that we can get we can experimentally get an idea as to how much of particles are present um, in a mole, right? That is the Avogadro constant's value can be figured out. So the equation to calculate Avogadro constant is L equals charge on 1 mole of electrons divided by charge on 1 electron. So 1 mole of electrons, it has a certain charge, and that divided by the charge of one single electron, you can get the number for the specified number for the Avogadro constant. Electron has a charge. That is also once again something that we have to do by experiment and find out. We can experiment and find out the charge of an electron to be 1.6 into 10 to the power minus 19 coulombs. So this is not something actually that you can do in a simple lab. So there are complicated mechanisms associated with finding the charge of an electron, but you are not required to know that for this exam, but it is useful to know how they do it. Basically what they do is, once again, we find out, we take the average values. That is, because these are very, very small numbers. 1.6 into 10 to the power minus 19 means there are 18 zeros before this, so it is actually very, very, very small, obviously. So that is not going to be easy for us to understand. So what we do is we take the average, right? We find out how many electrons get transferred, and after that we can get an average. That is another lesson for another day. But now let's try to figure out how this experiment is done. So if you go through paper 52, you will understand that these experiments are or rather provides the basis for paper 52. So I suggest that you go through these things very well, and it is not it is best if you can actually watch a lot of videos and get an idea as to how these things are done. So there are a lot of practicals carried out on YouTube. So check out some of the videos there. Specify this, now for example, finding the charge of one mole of electrons, then it will appear. There will be a lot of videos. Just watch a few of them when you are free. So then you have a better idea to how to answer these questions. The charge on 1 mole of electrons can be found from a simple electrolytic experiment. So this is the apparatus here. So we have a DC power supply, not AC. Then we have an ammeter. Then we have a variable resistor. Copper anode and cathode is there. And we have copper 2 sulfate solution as the electrolyte. So the procedure that we do is we weigh the pure copper anode and pure copper cathode separately, right? So we separately measure it. Then arrange the apparatus as shown in the diagram. The purpose that we have for this variable resistor is to make sure that our current is the same throughout our experiment. So we carry out the experiment in the same with using the same current. Then we send this measured current rather, or fixed or constant current for a constant period of time, or rather measured period of time, right? So the constant current for a measured or a fixed period of time, so we know how much of charge has been transferred. And then remove the cathode and anode, wash and dry. You have to wash it with distilled water and then propanone to make sure that nothing else is other than copper, nothing else is there in it. Then reweigh the cathode and anode. The separation of the removal of copper from the anode and the deposit of copper to the cathode will give us a ballpark figure of how much material is there in here, right? So that is how much of material has been removed or added. The cathode increases in mass because the copper is deposited. The anode decreases in mass because the copper goes into solution as copper ions. The decrease in mass of the anode is measured. This is preferred because the copper does not always stick to the cathode very well, right? So what we prefer is taking the measurement of the anode, that is the reduction of the weight in the anode. Why? Because not all the copper will get deposited on the cathode, but rather some of them will actually fall to the bottom of the container. A sample calculation is shown below using a current of 0.2 amperes for 34 minutes. Mass of the anode at start of the experiment is 56.53 grams. Anode at the end of the experiment is 56.40 grams. So the copper that has been removed is 0.13 grams. Then the quantity of charge passed is Q equals IT. Once again, the equation is there. Current is 0.20. T has to be taken in seconds. Therefore, you have to multiply 34 by 60 and you get 480 coulombs. So that means now this actually refers to the questions that we did earlier. By using 488 coulombs, we have obtained 0.13 grams of copper, right? So then to deposit 1 mole of copper, that is 63.5 grams, how much of a current is required, right? So that is what we'll have to figure out. So 0.13 gives 408. Then we use this equation here. This equation gives us the idea. 0.13. Remember, this here denominator and the multiplication should be the same. They have to be corresponding to one another. So 0.13 is for 408 coulombs. Then for 63.5, you multiply it by 63.5. Then you get a certain value. But once again, now we are trying to figure out our experiment is to find out L, right, by using the electron transfer, right, by using the electron transfer. So here we know, by equation we know that copper would require 2 electrons to produce 1 mole of copper, right? So then, because in this experimentation we are talking about 2 moles of electrons, we have to take half of that to find out the charge on 1 mole of electrons, right? So then we have to divide it by 2 or multiply by half. So then 99,600 coulombs is the charge of 1 mole of electrons. Then you know the charge of 1 electron. You divide 99,600 by 1.6 × 10 to the power minus 19. Then that will give you an answer 6.2 × 10 to the power 23 per mole. So this is quite similar to 6.02 × 10 to the power 23 per mole. That is the Avogadro's constant, right? So this is the experiment, and the calculation is how calculation has been described here. Now this is not something that I'm going to give you a note on. This is once again something that you have to develop your own experimental analysis and experimental steps. But if you need me to give you a note on this, please tell me, then I can give you notes on this as well. Write down a small note on how this is done. I will give you a rough sketch of the experiment. Write down calculating the Avogadro constant by an electrolytic method. Using electrolysis, we can obtain a value for Avogadro's constant in relation to the electrons. Then leave a line and write this equation. L is the Avogadro's constant. Avogadro's constant is equal to charge on 1 mole of electrons divided by charge on 1 electron. An experiment is set up as shown below. And after electrolysis, below readings are taken. Number 1, constant current that was provided throughout the experiment. The time through which the current was provided. Reduction, next point, third one, reduction of the mass of the anode. Leave a line and write. The reduced mass is a result of the charge that was provided. Using this figure, we can find the charge of 1 mole of electrons and that value divided by charge on 1 electron will give us a value for the Avogadro's constant. I hope you understood this. Please write a summary of the experiment that has been given here, and then if you have any questions, please raise them.